Hey guys, Mr. Milton here. Today we're going to look at triangle congruence by HL theorem notes. At the end of this video, you should be able to identify HL theorem between two triangles, and you should be able to prove two triangles are congruent using any of the 5 shortcuts. So far we've talked about 4 shortcuts. Here they go. Side, 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 angle, angle, side, angle, and angle, angle, side. Remember, with these shortcuts, these are theorems that allow us to prove show 3 things congruent and prove the entire triangles are congruent between them. Okay, so today we're learning the 5th shortcut or theorem postulate that proves 2 triangles congruent without showing every part. This theorem is called the hypotenuse leg theorem, and it states that if the hypotenuse of one leg of a right triangle is congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. Okay, and you should notice that the HL theorem only works with right triangles. Okay, so 3 things need to be true to use the HL theorem. First, it must be a right triangle. Okay. Second, the hypotenuses must be congruent. And then one pair of sides is congruent, or one pair of legs. Okay, so on the left you see a situation, an example of when the hypotenuse leg theorem would work. We have the right triangle, the hypotenuse, which is the side that is opposite the right angle, and then one of the legs congruent. So here it says, for these problems, it says, what additional piece of information is needed in each set of triangles to prove them congruent by the HL theorem? So in our first example here in A, as you look at it, I'll give you a second to look at it to see. Okay, and so I would notice that, hey, we have 2 sides congruent. It's not really enough unless we know that it's a right triangle. Okay, so if these were right triangles, or right angles here, that would make these right triangles, and then that would make their hypotenuses congruent. Okay, so either we would know that angle Q and angle T are right angles. Oops, right angles. Okay. And that will work out for us. I guess we could also know that angle R and angle B are right angles, but like they don't seem to be. Okay. So both of those are examples. Either Q and T are right angles, or that angle R and angle B are right angles. Okay, and that way we could use it with the HL theorem. Okay, here for B, okay, it says what additional information. So I'll start by saying avoid using RY is congruent to RY, because we already know that by the reflexive property. This is information that we don't need additional. We just need to recognize it from the beginning. So with that said, we would need to know that either TR is congruent to YE. I guess I should say EY. Or that TY was congruent to ER. Okay, so either of these would give us congruence in these 2 triangles by the HL theorem, because we'd have a right triangle, the hypotenuse being congruent, and a leg. So hypotenuse leg. All right. Next example, using algebra, it says what values for X and Y would make the triangles congruent by the HL theorem? So again, HL theorem just tells us that the hypotenuses are the same. And so as I look at this diagram, I'm like, okay, the hypotenuse in this triangle is 3y. The hypotenuse in the other is x plus 3. And the legs, the corresponding legs would be the same. So we have x and the y plus 1. Okay, as we look at this, these 2 equations, neither of them are really solvable individually, but luckily we've already been through algebra 1. Right, using algebra. And so we know that this is a system of equations. Okay, we should choose to solve this using substitution. And substitution allows us to say, since we know that x is y plus 1, in this next equation, instead of using x, we're going to substitute y plus 1 in and solve it. So I'm going to rewrite this first equation as 3y equals, instead of x, I'm substituting y plus 1 plus 3. And now I can solve this one. So I have 3y equals y plus 4. Subtract y from both sides, 2y equals 4. Y should equal 2. And now that I know that y equals 2, I can substitute this into this equation. X equals 2 plus 1, or 3. And I can make sure that works. Okay, so that would mean that this would be 6, and that would mean 3 plus 3, this would be 6. Hypotenuses work. 2 plus 1 is 3. X is 3. Legs work. It's a right triangle. These would be congruent by the HL theorem. All right, looking at some proofs. Okay, it says focus on the layout of the proof. So it says that complete each two-column proof, given that JL is perpendicular, remember this upside down T means perpendicular to LM, and LJ is perpendicular to JK. So, okay, so we already have that. Okay, those are the two things that's marked for us, right angles. Okay, then it tells us that MJ is congruent to KL, marked for us as well, and it wants us to prove that triangle JLM is congruent to LJK. Okay, cool. So as we look at this statement, we're looking at the first thing, JL is perpendicular to LM and LJ is perpendicular to JK. And so that wasn't information we had to work for. They told us that is given information. Number 2, it says that angle JLM and angle LJK are right angles. Okay. And so you might be like, well, didn't they just tell us that these are perpendicular? Yes, perpendicular lines create right angles. So it might seem repetitive or redundant, but it's not. We need to make sure that we're establishing that it's a right triangle if we're going to use the HL theorem. And so here we're going to say definition of perpendicular lines. You can see I made that simple. And so here we can say that triangle JLM and triangle LJK are right triangles. Okay, again, you might say, hey, that's a little redundant, right? Well, we have to establish that it's a right triangle, otherwise we won't be able to use the HL theorem, okay? And I might not be as stringent as making you do that, but fill in the blanks, make sure that we understand why that's a reasonable answer. All right, number 4, MJ is congruent to KL. Again, that's up here in our given information. So even though it's in the middle of our proof, it's still given. And then they give us the reason of a reflexive property of congruence. So reflexive means something's equal to itself. And so we should see that, hey, this is reflexive. And so we can say that LJ or JL is congruent to LJ. Again, if you said JL is congruent to JL, that's fine. But with our congruence statement, it's probably better to say JL and LJ. Okay, and then finally, triangle JLM is congruent to triangle LJK, and that is because of the HL theorem. Okay, all right. So a couple more proofs here. Let's go through these. Okay, and so I can make my two-column proof. Statement on one side, reason on the other. Okay, and so it says, given that B is the midpoint of AC, prove that triangle ABE is congruent to triangle CBD. So I'm going to start with that given. That B is the midpoint of AC. Okay, and yesterday we looked at how we could, in our last lesson, we looked at how we could really lay out the whole proof before if we wanted to. I'll do that with the second one here. I'll just walk through it with each step. So if B is the midpoint of AC, this doesn't mark anything as congruent for me, so I'm trying to see how I can use this information to say that two things are equal to each other. So since B is the midpoint of AC, what does that do? Well, that should cut this line in half. So I should know that this segment AB is congruent to that segment BC. Sorry, I didn't write the given. I said given, but didn't write it. All right. So now I know that AB is congruent to CB. Again, because that's what a midpoint does. Definition of midpoint. Number 3. So we need to add to that. So we got a couple things already marked for us, even though it wasn't given to us in the statement. It's given to us in the diagram. So I can say that EB is congruent to DB. That's given. Okay, so again, I'm going to mark these that, hey, these give me something's congruent to something. And then I have that angle C and angle A are right angles. Again, given. Okay. So from there, I probably want to say that angle C is congruent to angle A. And I can say definition of right angles, because all right angles are 90 degrees. Okay, gives me that. Able to say they're equal to each other and they're 90 degrees. Need both of those for HL theorem. And so finally, I'm able to say that triangle ABE is congruent to triangle CBD because of the HL theorem. All right. Finally, looking at this proof, we'll walk through it before we make our proof in this case. All right, so here, different color. All right, so I'm looking at it. They gave me a right angle. Great. They gave me this angle MLO and NLO being congruent to each other. And so I notice here that, well, we should know that LO is congruent to LO. Okay. And so as we look at this, we're given an angle, and a side. It's only giving us one side, but if we're stuck trying to find out what the HL theorem, we might be stuck here for a while. But if you heard what I said, we have angle, side. Okay, that's enough for us to prove that two triangles are congruent to each other. Okay, so even though it's the right triangle, it does not have to be the HL theorem. Okay, so we have our information here. Our given information, we have that one measure of our angle M is congruent to angle N. That was given. We have angle MLO is congruent to angle NLO, given. And then we have that LO is congruent to LO. And that wasn't given. Felt like we didn't have to work very hard for it, but it's a reflexive property. And so 1, 2, 3 things we were able to say are congruent. That should be enough for our shortcut, okay, confirming what we thought. And so we can say right now that triangle LMO is congruent to triangle LNO because of angle, side. Again, we have two angles and a non-included side, so angle, side theorem. And so we've proved what they asked us to prove. So notice we proved the triangle. We proved right triangles congruent without using the HL theorem. So it doesn't have to be the HL theorem just because you're using right triangles. But it does have to be a right triangle if you're going to use the HL theorem. Okay? So we now know 5 shortcuts to prove triangles are congruent. Side, 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 angle, and angle, angle, side. And we can show those in a proof. All right, see ya.